Welcome to today's explainer. Listen, if you're an 8th grader joining us today, I want you to go ahead and sit up, get focused, because we are skipping the boring agendas entirely. We're getting right to the good stuff. Today, we're exploring a concept our source calls the Trinity of Quadratics, where forms, functions, and faith are all tied together in one incredible mathematical package. Now, I know that might sound like some complicated math spell, but I promise you it's one of the most thrilling real-world concepts you're ever going to master.
I mean, really think about this for a second. How do engineers use math to perfectly land a reusable rocket on a tiny pad floating in the middle of the ocean? Or, how do they design a terrifying, stomach-dropping roller coaster that is completely 100% safe? How do professionals actually solve these massive, high-stakes problems in the real world? Well, the secret is, they don't just guess. No way. They rely on picking the exact right mathematical tools to perfectly map out curves, trajectories, and arcs.
But before we actually crack open that mathematical toolbox, our source material grounds this whole lesson in a really interesting perspective from Proverbs chapter 2, verse 6. It states, "For the Lord gives wisdom, from his mouth come knowledge and understanding." Just as this curriculum points out that God provides multiple perspectives to really grasp truth, while math actually gives us different equation forms to understand the full, complete picture of these beautiful curves we call parabolas. We aren't just looking at a problem from one single angle, we're hitting it from multiple angles to find that true understanding.
Okay, let's dive into this. To really get quadratics, you kind of need to stop thinking of them as just abstract numbers on a page and start seeing them as a flexible multi-tool. This is a tool used literally every single day by data scientists, aerospace engineers, and even professional athletes who are trying to analyze the absolute perfect arc of a basketball. And today, you're getting your hands on those very same tools.
So here is our mathematical toolbox for the day. We've got 3 specific tools at our disposal. Number 1 is standard form. Number 2 is vertex form. And number 3 is factored form. Think of these like choosing between a hammer, a wrench, or a screwdriver. They're all dealing with the exact same curve. But, you wouldn't use a hammer to drive in a screw, right? You have to pick the form that perfectly matches the problem you're trying to solve.
All right, let's look at tool number 1, standard form. This one is written as f of x equals ax squared plus bx plus c. Now, the absolutely crucial point here is why we use this one. Standard form is basically your go-to when you need to expand an equation or when you need to plug numbers into the quadratic formula to solve it. Plus, and this is super handy, right at the very end of the equation, that c value, it instantly gives you the y-intercept. It's just sitting right there in plain sight at 0, c.
Let's move to our second tool and see how this builds. This is vertex form, and it's written as f of x equals a times x minus h squared plus k. If you ever need to graph a parabola, hands down, this is the absolute best form to use. Why? Well, because it literally hands you the vertex, the peak or the lowest turning point of the curve, right there at the coordinates h, k. It is the ultimate tool for visualizing the maximum or minimum of your graph.
And rounding out our trio, the whole shebang, we have factored form. That's f of x equals a times x minus r1 times x minus r2. If you're trying to figure out exactly where your curve hits the ground level, which we call the x-intercepts or the roots, this is for sure the fastest way to do it. The roots, r1 and r2, are basically staring right back at you from inside those parentheses.
Okay, so how do these tools actually work together? It's kind of like a giant puzzle. If we take a standard form equation, let's say x squared plus 4x plus 3, and we factor it, we get our factored form, which is x plus 1 in parentheses times x plus 3 in parentheses. Once you have that factored form, it perfectly reveals our roots. If you set those to 0, you see the curve hits the ground at -1 and -3. And logically, the peak, the vertex, has to sit right dead in the middle of those roots, which is exactly at an x value of -2.
Now, what's really interesting here is that we can have 2 totally different looking equations that represent the exact same graph. They're just different views. Take a vertex form equation like f of x equals x minus 2 squared minus 5, and a standard form equation like f of x equals x squared minus 4x minus 1. If you were to multiply out that vertex form, you would land perfectly on that standard form. It's the exact same roller coaster, we're just looking at it from a different angle.
Okay, are you ready to play aerospace engineer for a minute? Let's transition to a massive real-world problem. We're going to use our new math tools to track an actual rocket launch. We need to figure out the rocket's starting point, exactly how high it's going to go, and exactly where it's going to hit the ground.
Let's say our rocket's flight path is tracked by the standard form equation -2x squared plus 8x plus 10.
Step 1. Engineers use the standard form to find the peak, using a neat little formula, negative b over 2a. Step 2. They seamlessly convert that into vertex form to perfectly sketch the physical path the rocket takes through the sky. And step 3, they factor that original equation into factored form to find exactly when and where the rocket impacts the ground. It's all three tools working perfectly together to track the whole journey.
All right, you've seen the experts do it. Now it's your turn. We're going to transition into testing your skills a bit. I want you to mentally roll up your sleeves as we tackle some homework-style questions. Let's see if you can pick the right tool for the job.
Let's try this one. If you're given the equation f of x equals x minus 1 times x plus 4, which form is this? Think about it. If you said factored form, you hit the nail right on the head. Now, what are the roots? By setting those parentheses to 0, you should immediately spot that the roots, which is where our graph crosses the x-axis, are a positive 1 and a negative 4. Boom, you just found the ground impact.
Okay, here's a bit of a curveball. You're given a vertex form equation, f of x equals x plus 2 squared minus 9. How in the world would you turn this back into standard form? Well, you'd grab your expanding tool, you'd multiply out that x plus 2 times x plus 2, and then just subtract the 9 at the end. That simple process of multiplying it out is exactly how you shift gears back into standard form.
Now we're throwing it in reverse. We have standard form, x squared plus 6x plus 9. How do you shift this view into vertex form? You're basically hunting for a perfect square. And actually, scratch that, it doesn't just happen to be one, it factors perfectly into x plus 3 squared. There was absolutely nothing left over, so your k-value is just 0, meaning the vertex is right at negative 3, 0. You're just translating the math into a much clearer picture.
Time for a quick tool check, pop quiz style. Which form is best for finding x-intercepts? If you're trying to find where that roller coaster bottoms out at ground level, which tool are you grabbing from the box? For sure, you should be reaching right for the factored form. It is literally designed to give you those x-intercepts super fast, with basically 0 extra calculations.
And this brings us right back to the real world. If you're NASA and you absolutely must know the maximum altitude a rocket will reach before it starts plummeting back to Earth, you need the peak, you need the vertex. Finding the maximum height of a thrown ball, a rocket, or even the lowest dip of a massive suspension bridge, this brilliantly illustrates the raw power of vertex form in the real world.
You guys have done an absolutely incredible job with the math today, but the source material for today's explainer from the HeroesmartAcademy Godly Learner series actually takes this a step further. They combine all this deep academic learning with a really earnest, grounded life lesson. Their philosophy is that true education simply must be guided by morality.
Our source poses a really profound question. What's the point of being smart if you just use it to make bad choices? It emphasizes this powerful idea that being supposedly educated but lacking an anchor of biblical morality will ultimately just lead to choices that end up hurting you and the people around you. Think about it. Math gives you the tools to build a rocket, but it's morality that guides where you point it.
And the source backs this up with a truly beautiful promise from Romans chapter 8, verses 6 through 7, which promises peace of mind to everyone who keeps their mind spiritual. It really highlights that keeping a spiritual mind brings true, lasting peace right alongside our academic knowledge. It's really all about balancing the raw processing power of your brain with the spiritual peace of your heart.
So, this curriculum leaves us with one final provocative thought. You've got the mathematical tools in your toolbox now, but will you use your knowledge just to be smart, or will you use it to build a life of true wisdom, morality, and peace? It challenges all of us to seek the full picture, both in the equations we solve and the lives we ultimately choose to live. Thanks so much for joining me on today's Explainer, and we'll see you next time.